A very good morning to all of you. I once again welcome you all to this current video lecture. From the last some couple of video lectures, we are discussing regarding the topic called as the alkenes. So from this alkene topic, we completed the different points from this chapter. In the last video lecture, we stopped at one important point that is called as the reactions given by these alkenes. So, in the last video lecture, we completed the different type of chemical reactions given by these alkenes of the type addition type. So, addition reactions we completed. Now, in the today's video lecture, we are going to take the next important type of reaction given by these alkenes, and that type of the name of that reaction is called as the cleavage reactions of alkenes. Now, what is by these cleavage reactions and what are the different examples of these cleavage reactions? So that we have to study in a today's video lecture. So before taking the different examples of this reaction, you must get an idea what is by this cleavage type of reaction. We know very well that this alkene compound consists of the functional group called as the C double bond C. So this type of functional group is present in a each and every alkene. So in the last chemical reaction, that is called as addition type of reaction, what happens? This C double bond C get converted into the C single bond C. So that reaction is called as the addition type of reaction. But now today we have to study the cleavage type of reactions. So what happens in the cleavage type of reactions? So this is a C double bond C. Now this C double bond C, what happens? It undergo cleavage reactions or it undergo degradation reaction, in which what happens, this C double bond C get break or get degrade to form the two different type of molecules. This single alkene compound get converted into the two different type of the molecules. So this type of reaction is called as the cleavage reaction, or it may called as the degradation reaction. It may called as the degradation reaction. And why this is so? Because single molecule get converted into the two different molecules. So this is simply called as the cleavage type of reaction. Now, what are the different examples of this type of the cleavage reactions that we have to study now? So two different type of the important cleavage reactions is there given by these alkenes. So first of all, we are going to take the first example of this cleavage reaction, and that is called as the ozonolysis reaction. This ozonolysis reaction is a best example of cleavage reactions given by these alkenes. Now we have to study what is by this ozonolysis. So if we split up this word ozonolysis, so what is the idea which we get from this ozonolysis? So ozono means it stands for ozone. We know the ozone molecule, that is a O3 molecule. This O3 is a ozone molecule. So ozone stands for this O3 molecule. Lysis means to break, to rupture, or to degrade something. So by the addition of this O3 or by the addition of this ozone molecule to a particular reactant, that is a alkene, the alkene molecule get degrade or it get break, and that's why this type of reaction is called as the ozonolysis reaction. Now what happens after the addition of this ozone? What type of product can be obtained? So for this purpose, we take here a general skeleton of this alkene molecule. So I take here a general skeleton of alkene as C double bond C. This is a general skeleton for any alkene. So whenever this alkene can be interact with the ozone molecule, when this alkene can be interact with the ozone molecule, that's O3, what happens? In a first step, we get an unstable molecule, that is, this is a C single bond C. There is addition of ozone molecule can be takes place across this carbon-carbon double bond, and this type of one unstable intermediate is obtained. Now this intermediate, this unstable species is called as the molozonide. This is called as the molozonide. This is a very unstable in nature. It is called as the molozonide. So what we take here, this ozone molecule get interact with this alkene. After that, this carbon double bond carbon get break, and there is a insertion or addition of this ozone can be takes place across the carbon-carbon double bond, and we get one unstable species that is called as the molozonide. After this molozonide formation can be takes place, we know that this is a highly unstable, so it get converted into the next stable species. It get converted into the next stable species, and that is a carbon, this is oxygen. So this type of a stable species can be obtained by or from this molozonide. Now this species is called as the stable as compared to this molozonide. So this species is now called as the ozonide. This is a ozonide formation can be takes place. So after the formation of this ozonide can be interact with zinc and water molecule. So what happens after the interaction of this ozonide with the zinc and H2O, there is a breaking of the bond can be takes place. So this breaking is there. This type of breaking can be takes place. And after this breaking or the split up of this ozonide yields or form the two different type of the molecules. So after such a type of breaking of the ozonide takes place, we get the two type of the different molecules as it may be C double bond C, and second is a again O, this is a C double bond O. So we can say that two different type of the carbonyl compounds can be obtained after the breaking or degradation of this ozonide can be takes place by the interaction with zinc and H2O. So this is a very simple type of cleavage reaction given by the alkenes called as the ozonolysis reaction. So what is by ozonolysis? So in a ozonolysis reaction, the given alkene molecule interacts with the ozone molecule. After the interaction, in the first step, it forms one unstable species that is called as the molozonide. This molozonide is called as a highly unstable. So it becomes stable by the conversion of this molozonide into the next chemical species that is called as the ozonide. So ozonide can be takes place. So once a ozonide is obtained, this ozonide get interact or react with a zinc and water molecule. After that, the breaking of the bond can be takes place, and you will get the two different type of the carbonyl compounds. So these carbonyl compounds may be of the type of two ketones or one ketone, one aldehyde, or it may be a mixture of a carbonyl compounds can be takes place. So this type of reaction is called as the ozonolysis reaction. Now in this reaction, a zinc can be used. So why we have to use the zinc? So zinc is used because it is a helpful to prevent the conversion of this carbonyl compound into the acid. This zinc is useful to prevent the conversion of these carbonyl compounds into acid. Why? Because it prevents the formation of H2O2. It prevents the formation of H2O2 of this H2O. H2O cannot get converted into the H2O2 due to the role of this zinc. And why H2O2 is not helpful? Because if the H2O2 is formed, this H2O2 is an oxidizing agent, so it may oxidize this carbonyl compound that is a ketone into the acid. This aldehyde into the acid, and that's why we can use here a zinc during this last step of this ozonolysis reaction. So this is a general skeleton of this ozonolysis reaction. After studying this general skeleton, if we take a specific example of this alkenes, so for this purpose I take here a next simple example of alkene, CH3 CH double bond CH2. So this is a simple example of this alkenes called as the propene. So now we are interested to study what is a ozonolysis reaction can be given by this type of the propene molecule. So again we have to take the similar steps. So in the first step, what happens? This propene interacts with the ozone. When it interacts with the ozone, what happens? In the first step, we get the intermediate that is called as the molozonide. So what type of molozonide is formed? So we get the molozonide, that is a C single bond C. Now what do I have to write here? To this first olefinic carbon, one methyl group and one hydrogen is attached. So I write here H. This is a CH3 single bond oxygen, single bond oxygen. Again single bond oxygen is there. This is from ozone. After that, what are the atoms attached to this second olefinic carbon? These are the two hydrogens. So first hydrogen, this is a second hydrogen. So what is the name of this compound? Again it is called as the molozonide. This is a molozonide. So this molozonide formation can be takes place. We know that this molozonide is a highly unstable. So again it get converted into the stable species that is called as the ozonide. So what type of ozonide is obtained? This is C single bond O. This is a carbon, single bond oxygen to the first olefinic carbon. what type of the groups are attached? One is a methyl group, one is a hydrogen atom. So we write here H, this is CH3, and to the second olefinic carbon, first hydrogen, and this is the second hydrogen. So what is the name of this compound now? This is called as the ozonide. So this is a ozonide formation can be takes place. This is a ozonide, and once we obtain this ozonide in the last step, what we have to do here? This ozonide can be interact with the zinc and water molecule, and after interaction of this ozonide with the zinc and water molecule, there is a breaking of the bond can be takes place. This type of bond breaking can be takes place, and finally, what is the product? So we will get here CH3 C double bond O single bond H, means we obtain here first product as CH3 C double bond O single bond H plus what is the second product here? It is a H single bond C double bond O single bond H. So we get here H single bond C double bond O single bond H. So we can say that after the interaction of this ozonide with the zinc and water molecule, two different type of the carbonyl compounds can be takes place. One compound is called as the acetaldehyde and second compound is called as the formaldehyde. So this is a very simple reaction of given by these alkenes, and that is called as the ozonolysis reaction. In this ozonolysis reaction, two type of the different type of the intermediates can be used, can be formed. One intermediate is called as a molozonide and second intermediate is called as the ozonide. After formation of this ozonide, we get the two different type of the carbonyl compounds. So this is a first important type of reaction called as the cleavage reaction, that is a ozonolysis reaction. After this ozonolysis reaction, we are going to take the next important reaction given by these alkenes. The second important cleavage reaction given by these alkenes is nothing but the interaction of these alkenes with a reagent called as cleavage reaction by KMnO4. This is a KMnO4 and NaIO4, that is called as the periodate. That is the interaction of these alkenes with a reagent called as the KMnO4 in the presence of sodium periodate, that is a NaIO4. So this, by interacting these alkene molecules with this type of reagent, that is a potassium permagnet and sodium periodate, what happens? A second type of cleavage reaction can be takes place. Now what is by this, or what type of product can be obtained by the interaction of this reagent, that we have to study now. So for this purpose, again I take here a general skeleton of these alkenes, that is C double bond C. So this is a general skeleton of these alkenes. So when these alkenes can be interact with the first reagent, that is called as the potassium permagnet. So first of all, these alkenes can be interact with the KMnO4. So what happens? We know very well that after the interaction of this KMnO4 with this alkene molecule, a diol can be takes place. A diol formation can be takes place. There is a C single bond OH, this single bond OH. So this type of the diol formation can be takes place. What do you mean by this diol? Diol means a formation of this 1,2 hydroxyl dihydroxyl compounds can be takes place. To the adjacent carbon, 2 OH group is there. So this is called as a diol. Di stands for 2 and OL stands for this OH group. So in the first step, this alkene interacts with the KMnO4 to form a 1,2 diol. And after the formation of this type of the 1,2 diol, what happens? This 1,2 diol interacts with the second reagent, that is called as the periodate. So this second reagent is a periodate, that is a Na plus, and this is a IO4, this is a minus. It is a sodium periodate. So this diol can be interact with this sodium periodate. Then what happens? Three different type of possibilities is there. Means this diol may get converted into carbon dioxide. It may get converted into the acid. It may form a CO2. It may form an acid, or it may form the third possibility as ketone. So these are the three different possibilities of formation of this the products given by this interaction of KMnO4 and sodium periodate with alkenes. it may form a mixture of either CO2 and acid, it may form a mixture of CO2 and ketone, or it may form a mixture of acid and ketone. So it depends upon what is the structure of the given alkenes. So this type of simple reaction is there called as the cleavage reactions given by this KMnO4. This is the general skeleton of this type of the chemical reaction. Now we are going to take a first simple example of this uh, the cleavage reaction. So for this purpose I take here the first example as CH3 single bond CH double bond C single bond CH3 and single bond CH3. So this type of reactant molecule we have to take here for the studying this type of the degradation reaction. Now what is the name of this reaction? This is a 1, 2, 3 and 4. So it is called as the 2-methyl 2-butene. So this 2-methyl 2-butene can be interact with these reagents. So in the first step it interacts with the reagent that is called as the KMnO4. It interacts with the KMnO4. So what happens? Again a diol formation can be takes place. So what type of diol is obtained? This is a CH3 single bond C single bond H. Now this double bond get converted into the single bond. So it is a single bond C CH3 single bond CH3, and at this carbon first OH is there, this is second OH is there. So we can say that a diol formation can be takes place after the interaction of this KMnO4 with the alkenes. Once we obtain this diol, what happens? This diol can be interact with now sodium periodate, that is a NaIO4. This sodium periodate can be interact with this diol. After this, what happens? A bond breaking can be takes place. Now which bond get break? So this type of bond breaking can be takes place, and after the breaking of this type of the bond can be takes place. So what we will get here? So from this left hand part, this is a CH3 CH and OH. What happens? This left hand side part or this part get converted into the first type of the product, and the second part get converted into the second type of the product. So what we will get here? We get here two different type of the products. First product is called as the CH3 C double bond O single bond OH. This is obtained from this left hand side part, that is a CH3 CH and OH. And from this second part, what we will get here? We get here the formation of ketone, that is a CH3 C double bond O single bond CH3. So we can say that when this 2-methyl 2-butene interacts with the KMnO4, first of all we get the diol. Once we obtain this diol, it interacts with the periodate, and this periodate breaks a bond between this second carbon and third carbon, and from this we get the two different type of the products. One is a acetic acid and second is called as the acetone. So this is the first simple example of this cleavage reactions. Now if I take the another type of reactant, for example if I take here a second example, CH double bond C single bond CH3 single bond CH3. So this is a second type of reactant molecule is there, CH double bond C single bond CH3 single bond CH3. Again we have to follow the same steps. Again this reactant molecule interacts with the KMnO4 in the first step. So what happens after the interaction of this KMnO4? We get the again diol. So what type of diol is obtained? This is a H single bond C. One hydrogen is remaining, that is a CH2. This is a CH2 is there. So what we have to write here? H single bond C single bond H. After that this get converted into the single bond. This is a C. What type of groups are attached to this second olefinic carbon? 1-methyl, and this is second methyl. So it is a CH3 single bond CH3 single bond OH single bond OH. So this type of diol formation can be takes place from this type of the particular reactant molecule. Once you obtain this type of the diol molecule, what happens in the next step? This diol can be interact with the periodate, that is a NaIO4. So what happens? The bond between these two carbons get break, and we obtain the two different type of the products. Now in this case the two different type of the product is from this left hand side part, this EH single bond C OH single bond EH. What happens? We get the CO2, that is a carbon dioxide formation can be takes place, plus from this second part, that is a H single bond, sorry, CH3 single bond CH3 single bond OH. From this second half part, we get the formation of ketone, that is a CH3 single bond C double bond O single bond CH3. So we can say that the two different type of the products is obtained. One is the carbon dioxide and second is called as the acetone. Now, if we look towards this type of the product formation from the given reactant molecule, we get some general ideas. What are the general ideas? So, whenever your reactant molecule is there, like this first. So, suppose if this reactant molecule at the terminal carbon, if at the terminal carbon two methyl groups are attached, if to the terminal carbon, if two methyl groups are attached, 100% you will get the formation of this type of the ketone molecule. You are getting my point. If this terminal carbon has the two methyl groups in a reactant molecule, 100%, what you will get here? You must get the formation of this type of the ketone molecule. This is the first general observation. The second thing is that if your olefinic carbon has one methyl group and one hydrogen, if your olefinic carbon has one methyl group and one hydrogen, what happens? You must get the formation of this type of the acid molecule. This is the second observation. And the third important observation is that if in your reactant molecule of alkene, if this carbon double bond carbon is present at the terminal carbon, if this carbon double bond carbon is present at the terminal side, at that time what happens? You get the formation of this type of the carbon dioxide. So these are the three different type of the important observations obtained from this type of the different cleavage type of reactions by KMnO4 and sodium periodate. So this is the second type of the important chemical reaction given by these alkenes called as the cleavage reaction. In this cleavage reaction, what happens? This is the two-step mechanism. In the first step, you will get the formation of diol. Once you obtain this diol can be interact with the sodium periodate. In this case, what happens? The bond between these two carbon get break, and you will get the either the possibility of three products. You may get CO2, you may get acid, or you may get the ketone. And this possibility of formation depends upon the respective structure of the alkenes. Either you will get acid plus ketone, or you may get here carbon dioxide and this type of the ketone. So this possibility of product formation depends upon the structure of the particular reactant molecule. So in the today's video lecture, we completed the two important reactions collectively called as the cleavage type of reactions given by these alkenes. The first reaction is called as the ozonolysis. The second reaction is called as the reaction of alkenes with the KMnO4 and sodium periodate. So this is a point called as the cleavage reactions given by these alkenes. So with this, there is a conclusion of this chapter number 2 called as the alkenes, a chemistry of hydrocarbons, in which we completed the alkenes subtopics. So this is the end of that particular alkenes topic. The remaining portion of the syllabus we will start in a next video lecture. So with this, today I stop here. Thank you so much.